which is perpendicular to the same plane are parallel. And conversely, if two parallel lines is perpendicular to a plane, the other is also. So as we can see, we have this line which is perpendicular to the plane and that line which is perpendicular to the plane. So these two lines is perpendicular to a plane. So we can conclude that they are parallel. A straight line is parallel to a given plane, which is parallel to the intersection of any plane through it with a given plane. So, as you can see, we have this line here, which is obviously parallel to this given plane. And and we have also another plane, which is the intersection of these two planes. And this line here and this line, which is the intersection of two planes, is parallel. For example, we have this straight line and this plane are parallel. This straight line covers this another plane. So, these two planes are perpendicular to this line. So, this line and this line are parallel. Theorem number 9. If two parallel planes is perpendicular to the same line, they are parallel. And conversely, if two parallel planes is perpendicular to a line, the other is also. So, for example, this line, that plane, and this plane. These two planes, the intersection is this line. So obviously, we can see that that plane and this plane are parallel. Because these two planes intersect at this straight line. Theorem number 10. If a plane is parallel to each of two intersecting lines, it is parallel to the plane of these lines. So, for example, we have this plane and these two intersecting lines. So, according to theorem 2, that a plane can be determined by two intersecting lines. So, we have a plane. Then, according to theorem 8, that this plane and this intersecting line which covers a plane, this plane and this plane is parallel. For instance, we have this point and this plane. According to theorem 11, this point which is not on a plane, this plane which contains this point is parallel to this plane. Number 12. Through one of two skew lines, there is one and only one plane parallel to this line.
Given this line and this line, these two non-parallel lines and a point not on it, these two non-parallel lines is parallel to the plane. Therefore, the theorem 13 is true. And plane 1 and plane 2. These two planes are parallel because these two intersecting lines is parallel to these two intersecting lines. They are parallel because the angle of this line is equal to the angle of this line. In our Pythagorean theorem, this line and that line has 90 degrees angle. Also the other line. Therefore, these two planes and that plane are parallel. Then it proves theorem 14. Given plane 1, plane 2, and plane 3. These three planes are equal. To prove that they are equal, we will create a diagonal. We will cut these three planes into two. So, we will cut started from this ellipse to this edge. The three planes have an equal angle because the angle of the plane 3 is equal to the plane 2, and also the angle of plane 2 is equal to the plane 1. So therefore, the theorem 15 is given these two rectangular solids, this one and this one. These solids consist of many planes. Given these two intersecting planes, they form a dihedral angles. Because dihedral angles are half of a plane and they meet at common edge. Also to the other one. The plane angles of these are equal. So therefore, the dihedral angles of this and this are equal. So the theorem 16 is given this wall and this floor. This wall and this floor is mutually perpendicular. So if we draw a line here, the line we draw here is perpendicular to the floor. So therefore, the theorem 17 is 2. Given these two planes, plane 1 and plane 2, their line of intersection is this one. The theorem 1 states that two intersecting planes meet in a straight line. We also have the floor. The floor, these two given planes is perpendicular to the floor, and the floor is perpendicular to the given line.
The intersection?
Plane M, plane N, and this line we will name it as line AB. To name the dihedral here, we have M dash AB dash N. That's how to determine and to name a dihedral angle. That's all.